This is problem 11.7 from chapter 11 of Brigham and Houston Fundamentals of Financial Management, Concise 9th edition. We're given a set of cash flows and told that a firm has a 14% weighted average cost of capital and is trying to evaluate these two projects. After-tax cash flows, including depreciation, are as follows. Now I'm going to just take this and copy these down because it's easier to work with in a column because of all the stuff we have to do. Alright, and then this is time 0, 1, 2, 3, 4, and 5. Alright, and the WACC is 14% for both projects. I'll center everything up to make my life easier. To calculate the NPV, I want the present value of the future cash flows would be equals to NPV, the 14%, and then cover up cash flows from period 1, 2, 3, 4, and 5. And I'm not going to show pennies, but that's 34,331. For project N, it comes out to 96,196. I'm going to subtract the initial outlay. That's how much money I have to put into the investment. It's 30,000 for this one, and it's 90,000 for that one. The net present value, or the NPV, is the present value of the future cash flows net of the initial outlay. So 34,331 minus 30,000 gives me a present value for project M of 4,331, and for project N it's 6,000. All right, so project N earns more money than project M. All right, so the IRR for both of these equals IRR, and then highlight cash flows from period 0 through period 5. So this includes the initial outlay. And I like to add a decimal point or two. 19.9, 16.8. The MIRR, you calculate the more or less the same way. You calculate, first you add all the values, and then the finance rate would be the weighted average cost of capital, and the reinvestment rate is the weighted average cost of capital. Hit OK. Add a decimal place. All right, to calculate the payback and the discounted payback, this will be for M and N. For project M, the crossover point occurs right at the end of year 3. So the payback period for project M is 3 years. If I do that for project N, I get my money back between the end of year 3 and the end of year 4. Okay? So it's at least 3 years, and then $6,000 is how much I need to earn during year 4 to break even. Going to earn 28,000 total, so about 6/28 of the year. So that'd be 3 years plus 6/28 of the year, or 3.214, or 3.221 years. All right, to do the discounted payback, rather than using the actual or nominal cash flows, I use the present value of the cash flows. So those would be all right. So now I've got the present value of the cash flows. Then I do the same basic calculation. Instead of using the nominal cash flows, I look for the point where the present value of the cash flows crosses over. So sometime between year 4 and year 5 is when the payback occurs for project M. And if we do that for project N, it's also somewhere between the end of year 4 and year 5. All right, so that would be 4 years plus the absolute value of 8.877 divided by the 5193. So similarly for the project N, it'd be the point where the $8,400 that is still outstanding at the end of year 4, 84,16,055, and the present value of the cash flows in year 5 is 14,542. So about 8,416 divided by 1,452 gives you the fraction of the years. Add that to 4 and you get the discounted payback. Students often have trouble with the payback period and the discounted payback period. It's a really simple concept. It's how long does it take to get your money back? Okay, so you get your money back a little faster with this project than this project. This project earns a higher rate of return than this project. This project has a higher net present value. If you're earning 16% on $90,000, that gives you more money than if you were earning 19% on only $30,000. And that's why this number is bigger. All right. Notice that the projects have the same timing. Okay. Well, let me go in order. Assuming the projects are independent, which one would you recommend? Both. If they are mutually exclusive, which one would you recommend? You can't have both. You can have neither. You can have M or N. What we would do is pick the project with the highest net present value because it earns the most money. Okay, N And the reasoning behind that, of course, is because it has a higher NPV. All right, and that is that simple. The one with the highest NPV is the best project. They both have the same cash flow timing pattern. Why is there a conflict? Well, I don't know about that. Both have the same timing pattern. I do know this. The conflict arises because while you're earning a higher rate of return on this one, you're earning it on less money. The conflict comes because you're earning a lower rate of return, but you're earning it on $90,000.